Hello dear students of 9th class. First of all, welcome you all to my YouTube channel Physics Concepts and Motivational Talks. ਮੈਨੂੰ ਉਮੀਦ ਹੈ ਤੁਸੀਂ ਪਹਿਲੇ ਵਾਲੀਆਂ ਵੀਡੀਓਜ਼ ਲੀਨੀਅਰ ਮੋਸ਼ਨ, ਸਰਕੂਲਰ ਮੋਸ਼ਨ, ਲਾਜ਼ ਆਫ ਮੋਸ਼ਨ ਐਂਡ ਗ੍ਰੈਵਿਟੇਸ਼ਨ ਚੰਗੀ ਤਰ੍ਹਾਂ ਦੇਖ ਲਈਆਂ ਹੋਣੀਆਂ ਔਰ ਤੁਹਾਨੂੰ ਸਮਝ ਵੀ ਆ ਗਈਆਂ ਹੋਣੀਆਂ। ਜੇ ਨਹੀਂ ਸਮਝ ਆਈਆਂ ਤਾਂ ਇੱਕ ਵਾਰੀ ਫੇਰ ਸਾਰੀਆਂ ਵੀਡੀਓ ਜਾ ਕੇ YouTube ਚੈਨਲ ਤੇ ਜਾ ਕੇ ਤੁਸੀਂ ਦੇਖ ਸਕਦੇ ਹੋ। ਅੱਜ ਦਾ ਟੌਪਿਕ ਸਾਡਾ ਹੈਗਾ ਵਰਕ, ਪਾਵਰ ਐਂਡ ਐਨਰਜੀ। ਵੈਰੀ ਸਿੰਪਲ ਟੌਪਿਕ ਜੋ ਮੈਂ ਇੱਥੇ ਬੋਰਡ ਤੇ ਲਿਖਿਆ ਹੋਇਆ ਹੈ, ਬਸ ਇਹ ਸਾਰਾ ਤੁਹਾਡਾ ਚੈਪਟਰ ਹੈ ਜੋ ਤੁਹਾਡੇ ਸਿਲੇਬਸ ਦੇ ਵਿੱਚ ਹੈ। ਤੁਹਾਨੂੰ ਤੁਹਾਡੇ ਸਾਰੇ ਕੁਐਸਚਨ ਇੱਥੋਂ ਸਾਰੇ ਕਲੀਅਰ ਹੋ ਜਾਣਗੇ। ਸੋ ਆਓ 10-15 ਮਿੰਟ ਮੇਰੇ ਨਾਲ ਜੁੜ ਕੇ ਆਪਾਂ ਕੋਸ਼ਿਸ਼ ਕਰੀਏ ਸਮਝਣ ਦੀ ਵਰਕ ਐਂਡ ਐਨਰਜੀ। ਨਾਓ first of all, what is work? Work, that is physical work that we study in this physics, is little bit different from the work that we do in daily life. In daily life, for example, a gatekeeper is doing his duty at the gate of any institute, hotel, anywhere. He is paid something because he is doing work, he is doing his duty. But according to physics, he is not doing any work. A teacher teaching in the class, teaching for half an hour, 1 hour, but he is not doing any work. So, interesting topic. Why a teacher teaching in the class, a gatekeeper doing his duty on the gate, they are not doing work? So because in physics, work is said to be done only, number one, if there is force acting upon the body, and if there is some displacement or distance covered by the body. If there is no distance covered by the body, if net displacement covered by the body or the person is zero, then according to physics, he is not doing any work. In other words, in physics, work is said to be done only whenever there is some motion. So, now motion can be done only if there is some force. Now, suppose we have a body and constant force F is acting upon the body. When constant force F is acting upon the body, suppose body is moving in this direction, and suppose S is the distance covered by the body in some time. When constant force F is acting upon it, then work done is given by F into S. So work done by a body or a force you can say, or a person you can say, is defined as the product of the force applied and the distance moved. So W is equal to F into S. It means if F is 0 or S is 0, there is no work done. For example, work done by a coolie taking some load on his head and standing at a place for about 1 hour. 0. No work is done by the coolie taking some load on his head and standing at a place. It means he is not moving. So displacement is 0. So work done by a coolie is 0. So the question may be asked, why the work done by a coolie taking some load on his head and standing at a place that is at rest is 0? So the answer is because net displacement is 0. If displacement is 0, no work is said to be done. Similarly, work done by teacher, because teacher is not doing teaching in the class, not doing any net displacement, not covering any net displacement, so work done by him 0. Work done by gatekeeper doing his duty, so there is no net displacement, net motion, so work done is 0. So engine pulling a train does work, because engine pulling a train is moving, so it is being displaced. So clear? So work is said to be done only when there is some motion, body is displaced from initial position. Now units of work done. If F is 1 Newton, S is 1 meter. then work done is said to be 1 joule. So joule is the unit of work done in SI system. So 1 joule we can define. So work done is said to be 1 joule if a force of 1 Newton displaces the body through a distance of 1 meter in its own direction. Because we are talking about constant force, means constant force having same magnitude and same direction is acting upon a body. And there is variable force, so work done formula may be different. So that you will study in higher classes. So if F is 0, S is 0, work done is 0, and unit of work done is 1 joule. Clear? So work is said to be done when a constant force acting upon a body displaces it through certain distance, and it is measured in joule. And when force of 1 Newton displaces the body through 1 meter, work is said to be 1 joule. This is SI unit of work done. Then come to energy. Now, energy is of many types. The ability to do work, capacity to do work is called energy. Energy is of many types: mechanical energy, electrical energy, light energy, heat energy, sound energy, magnetic energy. But in this chapter, we will discuss only mechanical energy, which is of 2 types: kinetic energy and potential energy. Now, kinetic energy is the energy possessed by the body due to its motion. That is, when body is moving, it will possess kinetic energy. And potential energy is the energy possessed by the body due to its position. Suppose body is raised to this height, it will have potential energy. Another height, it will have another potential energy. So its potential energy depends upon its position. Kinetic energy depends upon motion of the body. So more in the velocity of the body, more in the kinetic energy. So we will derive expression for both kinetic energy and potential energy. So ability to do work is called energy, and mechanical energy is of 2 types: kinetic energy and potential energy. Now to derive expression for kinetic energy, very simple. Suppose a body of mass m, a constant force F is acting upon it. Suppose body is displaced through distance s. Suppose u is the initial velocity of the body, v the final velocity of the body after covering a distance s. Let a is the acceleration of the body, uniform acceleration, because constant force is acting upon it. So force is given by F is equal to ma. So then work done by definition is given by W is equal to F into S. F is equal to ma by due to second law of motion. So ma into S. Now from equations of motion, we have final velocity v, initial velocity u, a, uniform acceleration, s distance covered. So we have studied this equation: v square minus u square is equal to 2as, or a is equal to v square minus u square upon 2s. So substitute the value of a in this equation. So we get w is equal to m v square minus u square upon 2s into s. So s cancels. So it is half m v square minus u square, or w is equal to half m v square, open this bracket, minus half m u square. What is half m v square? This is known as final kinetic energy, and half m u square is called initial kinetic energy. So it means work done in displacing the body of mass m through distance s by force F is nothing but change in energy of the body, change in kinetic energy of the body. So this is known as work energy theorem. So you can state work energy. What is work energy theorem? It states that amount of work done by a force on a body is equal to change in its kinetic energy. जिनी एनर्जी kinetic energy change हो जाएगी during the journey, that is called work done. So this is known as work energy theorem because it relates work with energy. Now, if u is 0, suppose body starts from rest and constant force starts acting when body was at rest, and after covering distance s, v is the velocity attained by the body. Then putting u is equal to 0 in this equation, the initial kinetic energy becomes 0. So this work done is given by half mv square, and this is known as kinetic energy of the body, because kinetic energy of the body is due to motion of the body. So kinetic energy of the body is given by half mv square. You can simply start from body at rest. You can take u 0, then you will get the same formula: w is equal to half mv square. This is general expression The body may start from any velocity with any velocity u and final velocity v when force F is active. So it means the change in kinetic energy between the two positions gives the work done by the force on the body, or work done is equal to change in kinetic energy. So kinetic energy is given by half mass into velocity square by virtue of its motion. It means more is the velocity, more is the kinetic energy. Then expression for potential energy. Now suppose a body of mass m, its weight will be mg. So weight always acts vertically downward because it is the force with which the body is attracted towards center of earth. So mg is the weight. So it means if I have to lift this body, so I have to apply force equal to weight of the body. So it means F is the force applied in the upward direction. So to lift a body through certain height, so we have to apply this constant force F is equal to mg, which is equal to weight of the body. So F is equal to mg. Suppose h is the height through which the body is raised, then work done will be force into distance again, force into height, or mg into h. So potential energy is equal to mgh. This is the expression for potential energy of a body raised through a height h, or you can say potential energy gained by the body when it is raised through height h. Very simple. M is the mass of the body, g is the acceleration due to gravity, which is 9.8 meter per second square, or h is the height through which the body is raised. So expression for potential energy is mgh, kinetic energy half mv square. So it is due to the position. As height changes, potential energy changes. More is the height, more the distance to which the body is raised, more is the potential energy. Then law of conservation of energy. Now, total energy of a system remains conserved. This is law in this universe. Total energy is conserved. That is, sum of kinetic energy and potential energy is always constant. So we can prove for a body falling freely under the effect of gravity, this law of conservation of energy is always obeyed. So suppose a body of mass m is dropped from height h, so when or the point A, when body is dropped means initial velocity of body u is 0. When body is coming down, suppose B the position at any point during its journey from the height h to the ground. V1 is the velocity of the body at this point, at point B. V the velocity of the body just above the surface of ground. Because when body is dropped, then due to acceleration to gravity, its velocity goes on increasing. So when it is dropped from height h, initial velocity is 0. And its velocity goes on increasing. Let V1 is the velocity at some point B in the path, and V the velocity when it just strikes the ground. So h is the total height from where the body is dropped. Let x is equal to distance between A and B, and this height will be h minus x. Clear? Now we can prove, we have to prove at point A, B and C, if total energy, that is kinetic energy and potential energy sum, remains constant, it means law of conservation of energy holds good for a body falling freely under the effect of gravity. So for that, energy at point A. Now at point A, initial velocity is 0. It means kinetic energy of the body is 0. Potential energy will be mgh. We have derived equation for potential energy. It means total energy at A. Total energy at point A will be sum of potential energy and kinetic energy, that is mgh plus 0 mgh. So it means total energy at point A is equal to mgh. Say this is equation number 5. At point B, no, potential energy will be mg into what is height at B. The height of point B from the ground is h minus x. H minus x. So it will be mg into h minus x plus kinetic energy will be half m v1 square, not 0, because v1 is the speed of the body at the point B. Now we can find the value of v1 square using same equation. V square minus u square equal to 2as. So we have v1 square, final velocity, initial velocity is 0 minus 0 2 A means G, X, distance covered X from A to B. So V1 square is equal to 2gx. If we substitute the value of V1 square here, it comes out to be kinetic energy half m 2gx. So 2 cancels, that is mgx. So that is the kinetic energy at point B is mg into x. Potential energy is mg into h minus x. If the total energy at B, mg into h minus x plus mgx. So mgx cancels, so it is mgh. So we have proved at point B, sum of kinetic energy as well as potential energy is also mg into h. Now at point C, just above the ground, h is 0, so potential energy is 0. Kinetic energy is half m v square, because v is the velocity with which it strikes the ground. So again, half m v square can be calculated as 2gh. By using same expression, v square minus u square is equal to 2as. So v square, initial velocity 0, so it will be 2gx for journey A to C. So then kinetic energy comes out to be mgx, 2 cancels, mgx, sorry. Total energy is equal to potential energy plus kinetic energy, m0 plus mgh, again mgh. It means we have proved at point A, B and C, well, at the highest point and at any point in between the highest point and the ground. So at 3 points, highest point, the point at certain height, h minus x, and just above the ground, sum of kinetic energy and potential energy is always constant. So this means total energy of freely falling body is always conserved. It means freely falling body obeys the law of conservation of energy. So total energy of a body remains constant. Then we define power. Power is rate of doing work, is called power. So power is equal to work upon time. So if W is equal to 1 joule, T is equal to 1 second, then power will be equal to 1 watt. So watt is the SI unit of power. Sometimes we use bigger unit, kilowatt, which is 1000 watt, and there is one more unit, 1 horsepower. So what is horsepower? It is the average power of a horse, work done by horse per second, you can say. Average power of a horse, which is equal to 746 watt. So this is the definition of 1 horse power. Then last topic is Eisenstein mass energy equivalence. Eisenstein mass energy equivalence, that mass and energy are interconvertible. This is Eisenstein mass energy equivalence. That Einstein says mass and energy are interconvertible, means mass can be converted into energy and energy can be converted into mass. And according to Einstein mass energy equivalence relation, E is equal to mc square, where c is the speed of light, m is the mass of the body. So when speed of the body is very large as compared to is comparable to the velocity of light, then E is equal to mc square. So mass also increases with the increase of velocity of the body. So when V is equal to c, we have already then m becomes infinite. So you can say, according to this Einstein theory, mass increases with the increase of velocity, and mass and energy are interconvertible. Mass can be converted into energy, energy can be converted into mass. So this is all about work, energy and power. So you have simply two expressions, one is kinetic energy and expression for potential energy and law of conservation of energy. So this is all about work, power, energy. The next chapter I will discuss sound, propagation of sound, and till then watch my videos. If you have any question, you can message me, or if you want some help, like you want notes of these topics, or you want some personal help means coaching on as online, or so you can text me on the comment section. So best of luck, be happy and enjoy.